Our next speaker is a master of hiding the serious within humor and hiding humor within the serious. With over 30 years of experience in the software industry, he is ideally positioned to educate us on exceptional software. Please welcome to the stage Robert Lefkowitz.
I had a brief moment of panic when Mark Schultz started talking about software development methodologies and what they've learned and how they're going to present that here, because tonight I'm going to talk about software development methodologies. And specifically, I've noticed that there are no open source specific software development methodologies. That is, there are open source practices, but methodologies like Scrum, like extreme programming, like the rational unified process, these are processes for developing software, and they're agnostic as to whether that software is open source or not. And it occurred to me that perhaps there should be a software development methodology. And the reason this thought occurred to me is because I spent a lot of my time in large corporations trying to get them to adopt open source software practices, because they don't want to adopt open source software necessarily, and plus adopting the practices seems more important than adopting the software. So when you start talking about what are those practices, it's sort of a collection of lots of little things, but there's no unifying way of bringing it all together. And large corporations like methodologies, they're sort of unifying methodologies. My company uses the Microsoft Solutions Framework as a methodology. And these methodologies tend to be very high level. So then eventually you drill down into the details, but you have to establish a framework around all the various possibilities to do this, and the idea is that it'll handle all kinds of projects, big ones and little ones. At the highest level, you have 5 stages of the software process. You provision, you plan, you build, you stabilize, and you deploy. Now, this doesn't seem like much of a methodology, but the trick is, can you get the 5,000 people in your IT department to agree that those are the 5 steps, and that's what you're going to call them? And the other important thing is, of course, to have a nice graphic that you can put up on everybody's cubicle wall to remind them that this is our methodology. We use the Microsoft Solutions Framework, and this is how we develop software. And by the way, how's your project going? Is it in InVision? This is the graphic we use. We prefer this one. Now, I don't have time today to go into all of the various things that you get into when you develop a methodology like this. So you not only have the process model, but you also have the team model and the roles various people play. And we're just not going to have time to get into that. So we're going to stick to the process model. Right? Now, the rational unified process is a different process model. In the company that I worked for before I came to this company, we used that one. And this is a different kind of a model where you don't envision, you have inception. See, and then you have elaboration, and then construction, and then transition. So it's completely different. 4 phases instead of 5, and then there's also, sort of going down the page, the various roles. Even the agile methodologies have sort of a similar flow. So you take extreme programming, and some of you may notice that this talk is an homage to Ken Beck. Then in chapter 21, what's the life cycle of an ideal extreme programming project? And you have 6 phases. In this case, although the last one being death, I'm not sure that it qualifies. You have exploration as opposed to envisioning. You have planning. You have iterations to release, and here's where you can see where that implementation thing sort of changes when you drill down to the next level. But at the highest level, you sort of have the same structure. Then you have productionizing and maintenance. So again, it's different, but subtly similar. So how do we construct this type of model that's specific to open source? Right, we want to start with the open source ethos. Right, what are the things that are important to capture in a model that that is, at this level. One that we could all agree that would capture the essence, and the details would vary from project to project as we build out to the lower levels, but to have that higher level graphic that we can put on every piece of equipment. Running code speaks is important. Peer review, early releases, and of course, given enough eyeballs, all bugs are shallow. That there is a community, right? Because these other methodologies were not developed with a context that the community has. How do we do this? So I have taken the liberty of constructing a proposal, but I need to give you a little bit more background into how one goes about constructing these things. The principles involved go back to Quintilian, who in 80 AD put out a series of works called the Institutes of Oratory. And in book 3, chapter 3, he lays out the 5 stages of the development of a logical argument. These 5 stages are inventio, which is getting the facts; dispositio, where you arrange the facts in the order in which you intend to have the maximum impact. Then you have to choose the exact wording that you are going to use to deliver this talk, and that is elocutio. Having done all this work, you must memorize the talk. You must commit it to memory, fix it in memory. And that, of course, is memoria. And then there is the delivery of the talk, which relates to the physical gestures and the demeanor of the presenter. Now, he spends a great deal of time in his confutation about the controversy as to whether memoria is in fact an integral part of the process. And he feels very strongly that it is. Now, if we take Quintilian's framework and we compare it to the Microsoft functions framework, you notice that there is a congruence. That is, first, you envision, right, inventio. You think of what it is that you were trying to do. Then you plan what it is that you were going to do, which is to arrange those things that you've decided to invent in some structure or order, a project. That would be disposition. Then you actually have to write the code, the specific lines of code that we're going to use in this work of logic. That is elocutio, or building as we would call it. Then the stabilization phase, where you fix the actual process that you are going, the program that you're going to deliver, pressing it to C. And then, of course, the deployment, the pronunciation, getting it out into people's hands. For those of you who are not visual people, but are more text-oriented, I have a table comparing the two. And you say, what's the big deal? Well, the big deal is if, in fact, as I have done, you go into a meeting of project managers and you say, oh, are we in the dispositio phase? They will argue with you and say, no, it's planning. Because it's something different. So there's a mapping. There's a mapping between the concepts as we understand them today and the concepts as Quintilian understood them in the 1st century AD. And so the construction of that mapping is really how we're going to create a framework which will be similar in structure, take advantage of the 2,000 years of Western civilization and thought that sort of has almost become a racial memory at this point, and make it unique to open source software. So now notice if we compare this to the rational unifying process, we have 4 of the 5 phases. And I believe the one that is missing is memoria, the one that was so controversial. Extreme programming also maps quite well onto this thing, again with a slightly different interpretation of elocutio. And this is where I take exception, of course, as does Quintilian with Get Back, in that, for those of you who've seen me speak before, I do not agree that a logically constructed argument and the delivery of it has to necessarily ever end. So a couple of other things inform the way that I arrived at constructing this model. And part of it was reading The Timeless Way of Building, right, in which Christopher Alexander observes that things are given their character not by the actual geometry of the place. So if you think of it as an oratorical or a program, not by the actual structure of the program, by the events that happen therein. And that was an important first cause to the chain of thought that ensued. And then I was studying the compendium of juggling. It turns out that there are two kinds of notations for juggling, which represent two kinds of views around how juggling ought to proceed. All right, so typical notation, the traditional notation, is called site swap notation, in which you keep track of where the balls want to go. So you say, oh, throw to the right, throw to the left, throw to the right, throw to the left. Right? And you give instructions as to where to throw. And that's one way of thinking about the problem. The other way of thinking about the problem, which is what causal diagrams do, is say at any point in time, a juggler has a problem. He's got a ball in each hand, and there's a ball headed for a hand. So causal diagramming is about tracking the problem. Oh, something coming this way. Oh. And the methodology then becomes not throw when you can, but throw when you must. And that is the secret. 70% of the code in MPS is exception handling code. That's why maintenance is associated. It's because focusing on the events, on the exceptions, on throwing when you must, right, is what makes your software exceptional. It's not the coolness of the program, but how gracefully it handles exceptions that make exceptional software. So with that in mind, I propose the exceptional software methodology. We maintain the 5 quintillion phases, but we map them slightly differently upon the activities that we do, and we take into account the open source ethos. Now the first thing that happens is, and you notice it in this Microsoft Solutions Framework, because it's iterative, because after you deploy then you start the next version, it's represented as a circle. And you go around in this circle, and the presumption with the Microsoft Solutions Framework is in the first iteration, you start at the beginning. Everything starts in the beginning. But we're going to start somewhere else. We are going to start at tomorrow. Because one way in which we're different is that when we release, we commit to a version control repository. Joel Spolsky has this Joel test, and one of the questions is, do you use version control software? And in open source projects, that seems like a silly question, but in large corporations, you pretty much don't use often version control software, because it doesn't matter. You don't have this notion of memory as remembering things. So we start with release early, release often. You don't start at envisioning, you don't start in constructing your argument, you start with taking whatever you have right now and releasing it correctly. Versioning it, of course. So now you've committed it to memory, and there you go, and you're off and running. And that is the second part. You run the software. None of the other methodologies include using the software as part of the methodology of developing it. That's, I think, an oversight. So I think that when we're talking about the delivery of operation, right, when we are in the pronunciatio phase, audience is important, community is important. Right? We've overlooked this step, deploying. And from there, you go to bug reports and submissions. We've released crappy software. We released it early, and it's got all these problems. It just keeps throwing exceptions, and people report these exceptions, and they possibly even send in patches. So now, this thing is also happening, and that's inventio. That's where the actual ideas come from. That's where the inventio is. The dispositio, the planning, is where you take that, and you triage all of these things that have come in. You decide which ones you want to put into the next release, and then you integrate it and go around the circle. So what is this? How is this different, despite the fact that it has the same 5 things? And the key distinction that's going to first be noticed by the IT department is there are no requirements. We don't have requirements, we just have bug reports. Right? And that's because there is no development. There's only maintenance. Just there's some maintenance, you know, a little more radical than others. All maintenance going on right now. Okay, so you think about it, why do we have requirements? Well, we have requirements for a very simple reason. Because we want to agree up front what it is that we want to do. This is a mistake. Well, the reason you want to do that is because you're afraid of making a mistake. You're afraid of implementing stuff that nobody's going to want to use. You're afraid that you're going to have lots of different versions of the same thing, and that will be exceptional. That will cause exceptions. It'll be wasted effort. Right? Well, if you parallelize this effort, and lots of different people are submitting lots of different patches for lots of different features, you may be doing more effort, but at least it's parallelized, it's not taking any more time. So the idea is what we're trying to do is eliminate a single point of failure. We don't want to have everything be single-threaded. The idea of requirements is to single-thread everything up front. Global lock. Let's decide what we're going to do. Nobody does anything until we've decided. We're just going to move that global lock to integration and say, no, everybody can go off and do whatever it is that you want to do, and we'll decide later whether it's a good idea or not. It's optimistic locking on the requirements. Now, the other thing that requirements introduce is the difficulty of being a customer. And Kempe talks about this a great deal in extreme programming, that being an XP customer is hard. Right? You have to make decisions, you have to write stories, you have to participate in these meetings where you prioritize these things. In the first iteration of extreme programming, the customer was actually supposed to write the test cases. Right, before, and then in later revisions, there was actually like a designated hitter that could write them for the customer. Right? So it's difficult to be a customer in something like XP, and also in Microsoft Solutions Framework. Right? The customer has to provide all this input on the requirements phase, but when you're using exceptional software methodology, it's easy to be a customer. All you have to do is complain when it doesn't do what you want it to. And use it when it does. Right? So, how easy is that? People want to do that kind of stuff. So here we have a methodology that follows Quintillian's principles, that multi-threads, parallelizing throughout most of the implementation cycle. And the way we arrive at that is by insisting that errors are not a bad thing. That what we're going to do is allow errors to happen, we're going to embrace those errors, and then we're going to code exception handling around them. Whether because the requirements, right? Requirements are just features that you didn't implement. What's the difference between something that you thought you implemented and it doesn't work and you actually didn't implement it? Right? So then you just have to promote unimplemented features and say, that's an exception. Right? And you handle it there. So I think that's the methodology. And I'm afraid, Mark Shuttleworth is going to be presenting his methodology on Thursday, so hopefully you will have either forgotten it by then, or will take the opportunity to see how his methodology is really just an elaboration of these principles to the next level of detail. Thank you very much.
Exceptional software means you must have failure before you can have success.